Welcome to ONF Spotlight on 5G transformation with open source. I am Guru Parulkar. I serve as the Executive Director of Open Networking Foundation and Executive Director of Stanford University's Platform Lab. This is the session, recorded keynote session on how private 4G, 5G over CBRS can enable a major transformation of enterprises and operators. I am delighted to introduce Preston Marshall as our keynote speaker. Preston has been a leader and a major force in the shared spectrum space. It is fair to say we wouldn't have precious CBRS and other shared spectrum resources without his efforts over the past 10 to 15 years, both in private and public sectors. Preston first funded and supported research on shared spectrum technologies while at DARPA. Then he rallied and advised the government on policies to create shared spectrum. Then he co-founded Wireless Innovation Forum and has been a co-chair of the Spectrum Sharing Committee. He also co-founded CBRS Alliance, a nonprofit industry association, and he has been the chairman of the board of directors of the Alliance. His official employer for the past several years has been Google, where he is engineering director for wireless architectures. Preston, thanks very much for doing this keynote, and please take it away.
Well, thank you, Guru, and I appreciate the offer to speak, and I appreciate everyone listening to the video. Hope you find it useful and provide some interest in CBRS and what it might be able to do for you. So Guru covered a lot of this, but you should understand I'm not a dispassionate analyst. I'm very much the advocate for this band. From the time we started this with PCAST, when I was at USC, through the public advocacy, the congressional hearings, and the organizations we formed at Google. So there are other people who can give you an unbiased version, but I am here to talk about the wonders that CBRS offers, particularly in terms of really opening up the ecosystems to a more diverse set of suppliers, and we'll talk about that in a bit. If you're interested in a lot of the details in this band, those have been established by the Wireless Innovation Forum, which set up the spectrum sharing rules. And I'm not going to cover them a lot here, but both of those organizations have really good webinars that are available that can walk through the mechanics of how you actually use CBRS. So here's the requisite spectrum chart you have to have in anything talking about wireless. CBRS is a new band. It's that little sliver below the arrow between 3.55 and 3.7 gigahertz. When we started this effort, there was a lot of, let's say, lack of interest because it was too high in frequency. You couldn't get great coverage out of it. Since the process began, 5G's come in, and everyone now wants mid-band. So we are right in the middle of where really all the activity in spectrum is focused today. We share the band with DoD and other radars, so we have spectrum sharing managed by a cloud service, and that's the first time we've ever really done that. What makes the band interesting and open is that instead of having exclusive licenses as typically done, we give people the right to purchase protection, but we do not give them exclusivity. So no one can buy spectrum and then just sit on it. No one can have competitive preclusion. It's completely open. Even if you buy the right to be protected, if you're not using the spectrum, anyone can. And that's really a new framework. So we don't see people purchase spectrum nationwide for one purpose. That purpose might not make market sense everywhere, and the spectrum remains fallow. So what makes it unique and open? First of all, and most conveniently, it is an international cellular band. It straddles 3GPP band 42 and 43. So what was exciting was that there was an industrial base already available to support 4G and 5G. We didn't have to create it. So here we had an opportunity to make use of Asia already having heavily invested in these frequencies. So these frequencies already existed. We just had to recruit the vendors. US mobile operators embraced it. You can't get it into a handset unless the mobile operators wanted it. So because the mobile operators eventually embraced, we then get this band in every handset, every mid and premium band handset. Initially, it's going to be band 48 with LTE. I'm proud to say there's a Google Pixel 4 up there. We are one of the ones selling it. And soon there'll be N48, which is the 5G band. So this gives an opportunity for everyone in the United States, enterprise individuals even, to use the same technology as the operators have, talk to the handset in the same way, and have all that functionality. So I'm somewhat of a policy wonk on spectrum, so I want to talk a little bit about the policy this was after, because I think when you talk about open software, you're talking about enabling really new models. And so the policy objectives here are that same intent, a different kind of model for wireless. So in 2012, the President's Council for Advisors for Science and Technology, I'm only going to say that once, did a report realizing the full potential of government-held spectrum to spur economic growth. Now, you might notice this is probably the only time anyone's talked about spectrum, not from the perspective of radios needing spectrum, but from the perspective that economic growth can utilize spectrum. And the idea was that the innovation that we see, particularly in the internet culture, in the software world, has existed because there was flexible, scalable access to the internet, to computing. And then when you look at how do we do spectrum with these auctions where they raise billions and billions of dollars, there's no way for someone to do the same thing in a spectrum dependent system that they could do if they were internet or compute scalable. So what we wanted was, how can people start imagine a venture capital, you want to start something, you want to raise $5 million, $10 million. You want to experiment in one city. It looks good, you want to expand it to other cities, and then you want to expand your scope. There's no way that model fit the way we did spectrum. And so CBRS is spectrum open to anybody. There'll be a secondary market so you can get access to spectrum hopefully many years after the auctions. But you have access to it right now, you can go and use it. So we thought it would fit the whole venture capital ecosystem that's been so successful in other parts of our society. And we talk about new technologies, but equally important, it would allow new business models to emerge well before they were ready to invest the billions and billions of dollars it would require to obtain spectrum at auction. So what we proposed was a single band. It would offer assured access to spectrum. Everyone has a right to get it. It would have multiple levels of protection, because we don't want to get in the argument, do you or don't you need protection? We've let it be a marketplace issue. Yes, you can get it. You have to pay for it. You can make a decision about whether that's worth it. We wanted growth paths for innovative ideas to scale. And we wanted to not break spectrum up into little stovepipes, which were so fragmented that they couldn't really support a robust supply chain. We didn't get everything, but we got the building blocks for a new ecosystem. So although we didn't capture the whole vision, there's a lot of uniqueness when you look at this band and you think about what will cellular systems look like it. Licensing is at a county level. Well, when we started this, we asked for licensing on a radio level. Eric Schmidt shared the study, and his idea was it would look kind of like AdWords. The FCC came out with census tracts, and then this administration's FCC raised it up to county. But it's still 22,000 individual licenses. So there's an opportunity for people to participate at a very local scale. And we're hoping, we'll see in another week or two, but we're hoping that when the curtain is raised on the auction, that a lot of the spectrum in the auction will be available in a secondary market, which will provide scalable, highly local, short-term, on-demand spectrum. We put a lot of work into promoting it. We'll see how that actually came out. 5G technology brings in a lot of opportunities to do highly flexible fixed networks. We've normally had, this is mobile spectrum and this is fixed. Here we have an opportunity to make it both. And we are right in the middle of really all the activity in the US on mid-band 5G. So it's going to be well supported, because we have below it just announced 345 to 355, and above it 37 to 42 in C-band. So 27% of the available mid-band spectrum in the United States is going to be CBRS. So that's the opportunity. This is an opportunity for anyone to do several things. First of all, leverage the same technology that the mobile operators have. I don't want to get into the Wi-Fi versus LTE and all that. I think it's enough to say that there are some unique features in the cellular infrastructure that have a lot of utility for some applications. And this gives an opportunity to essentially take that technology and be off the shelf, whether you're developing for it or whether you're a user for it. You can seamlessly extend the mobile device experience that everyone's become accustomed to through either a private or a non-operator network. Or you can repurpose that for other missions. And we see people coming into CBRS Alliance looking at using LTE and NR for things like surveillance, IIoT, which would not have made economic sense if you were buying SIM cards from carriers. And then ultimately, the real success here will be that what we see people do is develop, validate, and then really exploit new business models. So it's important to get new technology, but it's also interesting to see new business models emerge that couldn't emerge in the current exclusive use. And so, this is your chance to be your own cellular provider. So what makes it, again, unique? We haven't partitioned the spectrum, the users, and the supply chain into these little suboptimal stovepipes. We don't have a little piece for unlicensed, a little piece for mobile, a little piece for fixed broadband. It's all one band. It's an opportunity to create much more flexible technologies. It's an opportunity to create more efficient markets because they're not fragmented, create a large community. So people who might be selling fixed broadband like wireless ISPs can now also sell IoT services. They can sell mobile services with the same infrastructure. So we see a lot of opportunity here that just couldn't exist in the current model. Some of those opportunities might require spectrum protection, some won't, and that is a choice that you can make, presuming that there is a large amount of spectrum available in the secondary market. If you see the auction results come out and you see operators have tied up a lot of it, don't lose heart, because we know at least one of those operators is very interested in secondary market for its spectrum. When you take away competitive preclusion from a spectrum auction, so no one can keep you out of the band, then the incentive to not offer spectrum in the secondary market becomes greatly reduced. So we think we've created a more efficient market because no one has a business advantage in not putting spectrum into the marketplace. They may as well monetize it. So these are the use cases that are emerging. I'm sure if we come back here 5 years from now, it'll be a very different list. The number one, and I think the premier use case is neutral host. I build a network, a radio access network, and I serve multiple operators off of it. Because everybody gets this one band, I can build one set of networks and serve everyone. Compare that to DAS, where I have to build essentially a separate RAN for each operator. MNO and MVNO offload, deployed by a single MNO or MVNO. Private networks, where I essentially set up my own corporate network and use the 3GPP technology. We see hotels, for example, interested in using that for all of their IoT, move their paging networks onto it off of trunking systems. Makes a lot of sense. Hybrid networks, where you essentially build a private network, but you offer public services. So you would build your own private network and then offer perhaps neutral host services in the same network, and then fixed wireless broadband. All of these are being pursued to varying degrees. Neutral host and 3GPP-based private networks really weren't an option before, so they're really the new game on the table now that wasn't there before. So neutral host, let's talk about that a little bit. I also chair the business working group at CBRS Alliance. And this is the one that excites our members, I think, the most. You build a single network, single RAN, single EPC, but you support multiple operators. So you're essentially doing bandwidth as a service. And again, you have to contrast that with DAS, where the EPC is sort of reaching into the network and is being managed directly by the MNO or the end customer. It leverages the fact that everybody's on the same frequency. So a Verizon handset, a T-Mobile handset, or an AT&T handset all carries this band, and they're all authorized for use. It presumes that the managers are not directly managing the RAN. That's a big change to say, I'm going to let someone else handle my traffic for me, not just you build the radios, but build the management for it. It's a bit early to see how this emerges because these handsets have only been out this year. So we'll have to see as we get to 50% handset penetration, how much uptake. It is a different model than the operators are used to, but it has such incredible economic advantages that you're now sharing an infrastructure. It would represent, I said, an adoption of shared infrastructure rather than dedicated. There's a lot of different model where a bunch of operators are together and share a build. It could be provided as a service of a private network. It could be built as an alternative to DAS. Monetization, again, there's sort of two options occurring here. One is like DAS, where it's essentially a service to the building users, where it has no monetization. And the other is it is charged back to operators. So there's no question that this one is technically feasible, and it's even economically desirable. The challenge in it is coming up with a business model that works for all the parties. And that's a process that's ongoing. CBRS Alliance is trying to be the catalyst to bring these parties together. So MVNO offload is a similar option. You know, if you are, particularly if you're an MVNO and you already have a MNO carriage agreement, then you have the opportunity here to go and build a purpose-built network just to offload traffic in your high-density areas. You don't have to build a coverage network everywhere. You essentially go see where you're spending your money with the MNO, and then you build a network into those areas. It could be dedicated to a single MVNO. It could be multiple. Again, we're starting to have to see how these business cases work. Can be LTE or 5G. Could be LAA if you're a MNO. Not likely to be that if you are support from several MNOs in their public statements. And over the last 2 years, the public statements haven't changed that much. So, you know, we'll get a hint as to their real plans when we see what they did at the PAL auction. That will, I think, tell us a lot about their commitment to this. But certainly amongst the entities doing business, this looks like it's emerging quite rapidly. How far it goes, is it 100,000 radios? Is it 1 million radios? I think it's hard to tell that. And again, this one is somewhat gated by the handset penetration. And hybrid use cases essentially build your own carrier network. If you have a large campus, just build a network and put everything on it. It could be SCADA systems. It could be an LMR substitute. General Dynamics, or I'm sorry, Motorola has a really cute radio that looks like a LMR radio, push-to-talk radio, but it runs over LTE. So if you build your LTE infrastructure, you get your voice, paging, trunking, all of that for free. It's advancing because these use cases are not dependent on public handset adoption. A lot of security advantages. You could do local breakout. You can operate behind a firewall. You can provide admission control. We did a lot of work in setting up the protocols for the spectrum sharing to make them work through DHCP services, through firewalls, through NATs. So you can operate this even in the absence of fixed IP addresses. And a lot of really interesting new business cases emerging here. And then there's sort of the hybrid, again, where you just put a variety of these together and it inherits from all the other ones. So, you know, I describe these use cases as if they're unique. I think when we look back at them, they'll look something more like they went in a Cuisinart, and people are going to be drawing pieces from each one. So structural impacts. This is an opportunity to make cellular essentially a make or buy decision. Today, your only choice is you have to buy those services. You can now have a choice to make them. That has a lot of advantages in terms of control of the infrastructure, control of the investment, control over the future cost of the services, particularly where you have highly dense usage, like in an industrial campus or manufacturing facility. The technology isn't dictating the strategy. So if you think about today, if you are building a private network, you're pretty much limited to Wi-Fi. So this gives you the choice to use the available carrier-grade technologies. So we take technology as a discriminator off the table. Neutral host introduces some whole new structural entities into the wireless ecosystem. Wholesale providers that bring together multiple offerings. Integrators who might package bandwidth. No carrier wants to make a deal with 100,000 different buildings. So it's very likely what we'll see is integrators who become the brokers of this bandwidth. And this maybe in the end looks more like fiber, where we see a great decentralization of the actual transport based by whoever was the lowest marginal cost supplier. So if someone's already putting in Wi-Fi, putting in fiber, they're the natural guy to go and build wireless capacity for multiple comers. You don't have to build your own. Ultimately, if we really succeed in this, particularly if it takes off, and we've seen Germany have the same intent, although a different structural mechanism, we're going to drive 3GPP customers to become more diverse. Instead of being strictly an operator-focused technology, it could emerge that it starts to see the non-operator customers as a significant part of the ecosystem. And I think ultimately we're reducing the degree that spectrum is the barrier to entry in mobile. Pretty much if you want to be in mobile today, write a check for a couple $2 billion, that's step one. Wait 8 years for an auction is probably step 0. This changes it because it gives everyone an opportunity to get into mobile, recognizing the constraints, and start to do services, start to test markets, and perhaps deploy complete services. So where are we now? Good news, we've completed all of the government policy development. That took 6 years. We thought it was over when Obama signed his executive memorandum, but it's been about 6 years after that to get all of the policy regulations we could live with. The technical work to do spectrum sharing is achieved baseline capacity. Operating in the band, there are tens of thousands of devices operating fully capable in CBRS and fully compliant. And fixed broadband is deploying essentially as rapidly as they can convert existing towers from Part 90 to Part 96. What remains, and why I'm here to talk about this, is the marketplace validation of the vision. There's a lot of different use cases. They all seem to make sense when you put them on a spreadsheet, but we haven't seen how the market reacts to neutral hosts, to private LTE, to a distributed mobile infrastructure, a decentralized one. And so the real issue now is getting these ideas implemented, getting funding behind them, and seeing how the marketplace reacts to them. We'll learn a lot in the next week. I was kind of hoping that the auction would have ended by this time, and I could say this is what we learned from it. We know we saw we had 47 different bidders, I think on Arlington, Virginia. We had 27 in LA. So that's a great amount of oversubscription and an incredible amount of interest in the spectrum. So I think there is a lot of interest in these business cases, but we really haven't seen it. I can't point you towards this and that successful use case yet. Maybe someone on this call will come up with it. So a little bit, if you want a little more on this, particularly in the policy side, this is an unabashed book plug. I did write a book on this because I wanted to capture sort of the philosophy and the market implications on this, because we get very, very involved in the mechanics of this band, how we did propagation modeling, what the protocols look like, how we do certificates, all that. And I wanted to make sure that we didn't lose the big idea about how do you change the wireless model to make it more open, more flexible, more innovative, to create the opportunities for new kinds of competition. And so I did write a book on this. If you're interested in more on the implications of this, please take a look at it. And we also take a look at what it takes to expand around the world. It's fairly new. It's only 2 years old. So that's it. So thank you very much. I think Guru wants to grill me.
Not really, but Preston, again, thank you so much for a great talk. I really appreciate it, and appreciate you taking the time to come and do this keynote. Very, very good. Yeah, but I do have a few questions. I guess the first question is, I know you said you don't want to talk about Wi-Fi versus CBRS thing, but I would still want to ask you about how do you see Wi-Fi 6 and 4G, 5G over CBRS in a private enterprise network setting? Why should an enterprise consider LTE 5G over CBRS over Wi-Fi 6?
So as long as we limit that to not which is better, but which is better for them, it's a lot easier discussion. We're good members of Wi-Fi Forward and all that. There are features in LTE and particularly in 5G that I think have value for many users of communications. 5G has slicing, so you can manage bandwidth in very, very fine amounts. It has admission control, so you can just keep bad devices off as compared to the process in Wi-Fi. We have a security architecture that does not, that is implemented, I think, more out of the box seamlessly with the SIM cards than typical implementations in Wi-Fi, which start to look like a party line in practice. So, and the ability to manage the network. So Wi-Fi was built to be very, very simple and elegant in its simplicity. It's Metcalfe's Ethernet. LTE was built by people who built complex switches. So they both move towards each other. We see in Wi-Fi that they tried to add on more and more manageability. And we've also seen the carriers looking to see things become simpler so they can make use of commodity switches, what ONF works on. So they're still far enough apart that I think they're very differentiable. So I look at if you really want to manage your network, if you want to guarantee QoS to individual devices, if you want to put some devices on best efforts and some on guaranteed performance, if you're in a very dense environment and you want a lot of nulling behavior in your antennas, then 5G with the beamforming is going to be a real win. As an academic, I tend not to like listen before talk MAC layers. If I'm managing all the emissions in a building, it makes more sense to centrally manage that timing than just to have the collisions of an LBT layer. So, I believe, and I've not yet got the experiments, that you can build much denser networks with the LTE technology because I don't have the exponential back off of Wi-Fi. So I think there's a number of cases. They're not applicable to everybody. It's not that everyone should get rid of Wi-Fi and go switch over to NR, but I think there are people that will make great use of the unique features of LTE in something other than an operator setting. That's a long way to get around low Wi-Fi.
No, I think that is very good. I mean, this is a perfect answer. But tell me, you did talk about how CBRS solutions are part of handsets that are coming out. But tell me, where do you see these interfaces and chips available for a wide variety of other devices, and whether the price and widely availability will all come together? Because that's what Wi-Fi offers. And if some of the use cases you're talking about, if they were to take off, we will need these interfaces that are embedded in all these devices, and they are available at a price point that one can go buy and deploy, right?
Correct. And the good news here is CBRS doesn't have to make this happen. If you look at the, certainly the business plan of the carriers, ARPU is what it is. And so all the money to pay for this infrastructure comes from new customers, and they're generally not people, they're things. So certainly the cellular industry is focused on getting to price points that make it sensible for devices like at least industrial thermostats and such, to make use of the technology. We are now right in the middle of the two big 5G initiatives, the one the White House announced last week below us, and of course, C-band, that ongoing drama above us. And so it's very clear we are going to be sucked along by that traffic. You're just not going to put band 48 or N48. You're not going to leave it out. So I think there's an entire cellular industry that really needs those customers. They need it for their subscription services, but they're also going to carry along the supply chain for private networks and other kind of third-party networks. I think part of the real attraction of CBRS is the fact that we don't have to create our own supply chains. That actually the people who you might be using CBRS to compete with are creating the very supply chain you need to compete with them.
Excellent, very good, very good insight. Preston, you talked about, in your talk primarily in the context of United States. Our audience is global, so I would love for you to spend some time to say how are these similar things happening in the rest of the world.
But let's admit it, it's the most forward-thinking spectrum regulator in the world. Good and bad ideas in spectrum policy seem to start here. Some have been massively successful with unlicensed, some paying off national debt with auctions you can challenge. So I do think it's not surprising that the US did it first. The rest of the world is watching. I haven't done a lot of international travel recently, besides COVID, because I think we have to prove in the United States that there's demand for these third parties, that there's an economic base. Most regulators in the world have some degree of regulatory capture. It's going to take other entities come forward and saying, look what's happening in the United States. There's CBRS envy. We'll have to create it. It's probably not going to come from regulators. So we've seen in Germany that they've got local licenses. And I think I saw announced, I think it was Bosch and BMW. I'm hoping that they'll give me samples. And so I think they're trying to do a CBRS-like thing with somewhat different regime, but the same intent. I think the idea is to get spectrum into more people's hands. Different regulators can do it different ways. Ofcom is certainly talking about different ways of doing the same thing. But I think it's not a matter of going over there and just doing lots of PowerPoint in front of them. I think we have to show in the United States that we create economic activity. If we create the economic activity and we create new services, then people will follow. They're going to sit on
if nothing else, if our FCC can raise whatever that 2.4 or 4.2 billion dollars by the auction, if nothing else, that itself is pretty attractive, right, for others to follow and do something in this space.
C-band will raise more. I mean, it's.
Oh yeah, of course.
Yeah, I mean, it's an interesting question whether lots of money in auction is good or bad. Money in auction is not money in infrastructure. No one can use a radio that someone's paying off their auction.
No, very valid point. So you did talk about economics. If we can be successful, then others will. And you did mention in your talk about business models. So maybe I can ask the question one of two ways. One is that imagine you are a venture capitalist on Sand Hill Road and you wanted to invest in CBRS related opportunities. What will be some of the things you would want to invest in?
If I could do that, I wouldn't have to work for a living. I think there's some areas that are deeply underserved and there's no incumbency to beat out. I think the Internet of Things, besides being massively hyped and overhyped, very clearly the future is not handsets. And so so certainly looking at, I question whether people are going to do brain surgery over wireless, despite one of the operators' ads showing that. But I think there's a lot of things you want to do over wireless. Wi-Fi does have the tragedy of the commons problem. And so I think there's a good marketplace there for IoT. At CBRS Alliance, I think we're now 178 company members. And at the business working group that I run, I asked a question about the LTE configurations, up, down, link configs. The operator community within CBRS Alliance is all in the very downlink, small uplink, big downlink, because that's the model for mobile carriers. And when they did a show of hands, 2/3 of the hands went up with heavy uplink dominated. Their use cases were very, very different than the operators. And I think that's good. I think, why would you want to chase Verizon? The people are looking for different uses of it with surveillance, control, security. And I think that's a good move. They're going where the operators can't, which are heavily uplink dominated systems. So I think they're in the right head. That would be my path. Don't chase the use cases there are already people in. I think there's lots of things that we could never do because we never really had disciplined communications media that were available other than to major operators.
Very good. Let me see. And you said 26% of the spectrum. I'm sorry, I don't pay as much attention to that, so I missed that. So can you say a little bit more about, is the spectrum already allocated to CBRS is large enough that lots of exciting use cases can happen and they can scale? Or you think we need more spectrum in order to do the kind of use cases we need to do?
No one ever has enough money or spectrum. 150 megahertz is a massive amount of spectrum. It's as much spectrum as some of operators had just several years ago. So I'm not worried that 150 megahertz is not enough to be a good use, meaningful. It is. What we want to do is avoid splitting it into 3 or 4, 30 and 40 megahertz, which is what we've traditionally done. Is every time people want spectrum, we take something and carve it up. So by keeping it large, there's a lot of spectrum in rural where they can do fixed. In cities, there's a lot of channels for 5G. Those don't overlap. We can use the same spectrum for both. The importance of the 27 megahertz is that the supply chain is going to naturally bring CBRS along. We're right in the middle of another 75%, with assuming the 100 megahertz from DoD goes into mid-band. I think the FCC's talked about trying to even get that done before 21. And the C-band auction is not too far away. And so that's 299 megahertz or something, and another 100, so there's 400 there. So that's going to have it's both competitive to CBRS, but it also is going to enrich in the supply chain. And a rich supply chain brings down costs and opens up these use cases that we could never do if we were the sole advocate for this stuff.
Okay, so I guess those are the questions I have. Anything that I should have asked and didn't ask?
I always ask that question, and people. No, I think we've covered it. I think it's an opportunity for people to go and explore. There's a lot of stuff out there on it. The industry press has been very excited by CBRS, so people are interested. This talk was really sketchy on the mechanics and all. But we've got a lot of resources out there that people can go and find and kind of dig into it. And then if it doesn't make sense to you, come talk to us, because maybe we just haven't done a good job explaining something.
No, I think you did a great job. So thank you again, Preston, really appreciate it. And with that, I guess this is end of our recorded keynote. And I hope all of you like it as much as I did and find it very useful. So thank you everyone for participating and listening to it.
Thank you all. Good day.